Hi, I'm Patty with Amplify Science. I'm going to lead you through this unit orientation video for the kindergarten unit, Sunlight and Weather. In Sunlight and Weather, students take on the role of weather scientists as they figure out the anchor phenomenon in their unit. They work to help investigate the difference between playground temperatures at different schools and propose solutions to a playground flooding problem. Over the course of the unit, students construct a foundational understanding of how sunlight warms the Earth's surface and some of the effects that has on temperature. Students are introduced to the problem that children at Woodland and Carver Elementary Schools are not comfortable outside during their recess times. The students at Carver Elementary are too cold in the morning, and the Woodland students are too hot in the afternoon when they go out to recess. The school principals from these schools need your class's help as student weather scientists to help them explain the difference in playground temperatures. Students gather data from models of the sun and of the Earth's surface, and they observe their own playground to figure out how sunlight causes changes in the temperature on different surfaces. Students then use models to figure out why the Woodlands playground sometimes floods as they explore a bit about severe weather. As they work through the 5 chapters, they gather evidence from multiple sources by doing, talking, reading, writing, and visualizing. Their explanations become more complex over time as they construct scientific explanations that show their understanding of how different surfaces are affected by sunlight and how the number of hours the sunlight has been shining will make a difference in the playground temperature. This unit is a modeling unit. In their role as weather scientists, students develop skills with the science and engineering practice, developing and using models, with a particular focus on using models to investigate the effect of sunlight on the Earth's surface. Students use data from their observations to explain the differences in the playgrounds and make predictions. The focal cross-cutting concept in this unit is cause and effect, and students have chances throughout the unit to consider how sunlight and surfaces affect temperatures on the playgrounds. Every Amplify Science elementary unit also includes a focal sense-making strategy, which students leverage as they read and also during investigation. This unit's sense-making strategy is making predictions. Like most units in Amplify Science K-5, the main writing genre is explanation. So that's the overview. Now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomenon. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight a few key evidence sources students use. But remember, in every chapter, and indeed in every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students are introduced to the phenomenon and work to answer the question, what's the weather like on the playgrounds? They learn to describe different kinds of weather in this chapter. They figure this out by observing and recording weather at their own school and participating in a movement routine to show weather types. They read a book that helps them describe temperature and use thermometers to take measurements. Then they construct weather graphs to analyze weather data from each school. At the end of Chapter 1, students return to the anchor phenomenon. They explain that the weather at Carver Elementary and Woodland Elementary is similar. Both schools have many sunny days and some cloudy, windy, or rainy days. The type of weather at each school must not be causing the difference in their playground's temperature. In Chapter 2, students explore to find out why the playgrounds get warm. They figure out that the surfaces of the playgrounds get warm because sunlight shines on the surfaces during the day. Key evidence sources in this chapter include using a model to investigate the effect of sunlight on Earth's surface and then graphing the results. Students also measure and record temperatures on their school's playground to compare to the results of this model. At the end of Chapter 2, students are able to explain that the surface of the playgrounds gets warm because sunlight shines on the surfaces during the day. In Chapter 3, students come to understand why the playgrounds are warmer in the afternoon. Students figure this out by collecting evidence from reading the book, getting warm in the sunlight, and then revisiting the warming model to watch for warming over time. They participate in a think and walk to choose photographs of surfaces that have had sunlight shining on them for longer periods of time. And with the use of explanation language frames, they explain why a surface gets warmer over time. At the end of Chapter 3, students are able to explain that the playgrounds at both schools are warmer in the afternoon than in the morning because sunlight has been shining on the surfaces for a longer time. In Chapter 4, students work to figure out why Woodland Elementary School's playground is always warmer during recess. The lessons lead students to figure out that different surfaces become different temperatures even with the same amounts of sunlight. As students continue to learn about how models can help then predict or explain, key evidence sources in the chapter include using a colored surfaces model to investigate sunlight's effect on pale and dark surfaces, and revisiting the Handbook of Models to see how models can help us investigate one thing at a time. By the end of Chapter 4, students explain that Woodland Elementary's playground has a darker surface than Carver Elementary's playground. Woodland's playground is warmer because dark surfaces get warmer than pale surfaces when the sun shines on them. Chapter 5 addresses the idea that sometimes severe weather affects people and sometimes it doesn't, as students work to figure out why Woodland Elementary's playground floods, but Carver's playground has not flooded. In this chapter, students read about predicting severe weather, and they use flooding models to investigate why one playground floods. They analyze the data from their investigations with the models to explain that Woodland's playground floods after severe rain because it has a solid surface that does not absorb water, while Carver's playground has a gravel surface that rainwater can soak into. Looking at cause and effect relationships and patterns in data throughout the unit helps students make sense of observations and helps them make predictions. Well, I hope that you're feeling excited to dig into this unit this spring and that this gave you a brief introduction to sunlight and weather as you are beginning to prepare for instruction. You can use any combination of the platform resources and lessons, as well as the remote resources to best suit the needs of your group. Watch in March for a video coming on the progress build of conceptual ideas developed within this unit and the wealth of formative assessments that are built into the platform lessons to help you get information on where your students are in understanding these big ideas. I'm Patty Works, and my email address is pworks@amplify.com. Please feel free to contact me with any questions or to set up a time to work together on planning for Amplify Science. Thank you.